Okay. We are in the home stretch. So, at this point, you should have this section done, where you have all of your x components filled in and all of your y components filled in. Okay. So what we're going to do down below is we're going to add vector A to vector D. So, I'm just going to make a sketch of what's happening. Okay? You don't have to do this, but I recommend it. So, I'm just going to make that free body sketch, and I'm going to go, okay, hey, vector A, that's 25 meters per second. So there's vector A, 25 meters per second at 40 degrees. And then I have vector D, which is 11.4 at 270, which is like this. Now, here's the deal. When I look at this, okay, here's my vector A, here's my vector D. I got to figure that that resultant is going to be somewhere in this neighborhood, okay? It's going to be somewhere, and I drew vector A. Vector A should be a lot bigger than this, up like that. But at least it's going to be somewhere in this area. So if I get a resultant that's somewhere over here, in like that second or third quadrant, I've done something wrong, okay? This is just a sketch so I can see what I'm going to do. Now, if you want to sketch it tip to tail, you could go, okay, there's vector A, there's vector D, boom, there's my resultant, okay? You don't have to do that, but it's a good idea, so again, you can see kind of where you're going to end up. So, here's what's most important. You're going to draw a chart, okay, like I have back here. So, you've got X, you have Y, vector A, vector D, sigma, boom, like this. On the test on Friday, when I give you a problem like this, and I'm going to, I promise you, if I don't see this chart, I'm going to quit grading. And here's the reason why. This forces you to stay organized, okay? It forces you to keep everything sequential. I can follow exactly what you have done, and it isn't just a bunch of random numbers that are written down, okay? So that's going to be the key to this. So you already have the x and y components. So all I'm going to do is I'm going to write these in, okay? So I'm going to take the x component of A, which is 19.2 meters per second, and the y component of A, which is 16.1. All I did was just go up here. And then D's x component is 0. And then D's x component is negative 11.4. Okay? That's all I did. I just wrote down the numbers. Now I'm going to add these together. I'm going to get 19.2. And then I'm going to get 4.7. Okay? Literally. This sigma just means sum. I'm just going to add these together. 19.2 plus 0. Check my math. I think you're going to get 19.2. 16.1 and negative 11.4, you're going to get 4.7. So, here's my x component sum, here's my y component sum. Okay? Now, this is the most critical thing that you have to do next. Okay? You have to do this. Now, go out here and make a sketch of a new triangle. It doesn't have to be to scale, it's just a sketch. So come out here and go, okay, I got 19.2, that's my x component. I've got a y component of 4.7, okay, got that. And then I can draw that hypotenuse, which is my resultant. So what you've got is that you've got one leg, and always draw your x component first. Here's my x component. From the end of that, I've got my y component, which is 4.7. Now I'm going to do the Pythagorean theorem. I'm going to take 19.2 squared plus 4.7 squared, and then I'm going to take the square root of all that. You all have done this before. You all have been in geometry. Okay? It's just the Pythagorean theorem. A squared plus b squared equals c squared. So then, if you do that, you get a resultant of 19.8 meters per second. Okay? So if you take 19.2 squared plus 4.7 squared, you get 19.8 meters per second. And again, these all are in meters per second. We haven't changed any of the units. So we got 19.8. Now, at this point, this is incomplete. If you just tell me the velocity is 19.8 meters per second, I don't know what that means. Okay? If you give me an angle, then it becomes a vector quantity. Right now, this is just speed. It's just a scalar quantity. So what I would recommend, I'm trying to find this angle. So I would do the inverse tangent of 4.7 divided by 19.2. Now, again, here's the old school way of doing this. On the old school way, you would actually take 4.7 and divide that by 19.2. You would do that. Okay, you would get a decimal. Then you would come to this table and you would find, and you would look up the tangents, you would find the angle that had that numeric value when you took 4.7 and divided it by 19.2. That's what you'd have to do. And then you'd find the angle. Now, conveniently, your calculators do inverse tangents, and it's simple. So if you do that, you get 13.8 degrees. So here's your answer on down here where it says A plus D. I want to make sure everybody's cool with this. So the sum of your x components is 19.2 meters per second. The sum of your y components is 4.7 meters per second. So that's that. Then your resultant is going to be 19.8 meters per second at 13.8 degrees. Okay? So, here's your answer for about down there about 2/3 of the way where it says A plus D. Your x component adds up to 19.2. Your y component adds up to 4.7. Here's your resultant. Okay? Now, we need to play the what if game. And your calculator is going to lie to you. Okay? And you're going, no, Mr. Burkamp, my calculator won't lie to you. Lie to me? No. Yes, it will. It will roll you under the bus. So we're going to play the what if game. And we're going to say, what if that x component had been negative 19.2 and the y component had been 4.7? Okay, this is where your calculator would lie to you. So now if you make that sketch, you're going to come over here at 19.2 meters per second, and you're going to go up 4.7, and you're going to have your resultant. Now, your resultant is still the same. Doesn't make any difference. That's still 19.2 squared plus 4.7 squared. Your resultant is still going to be the same. That number is not going to change. That resultant is still going to be 19.8 meters per second. Now, if you punch into your calculator the inverse tangent of 4.7, let me move that up a little bit. If you punch into your calculator the inverse tangent of 4.7 divided by negative 19.2, and play along in the studio audience if you would like, 4.7 divided by negative 19.2, here's what your calculator will tell you the angle is. Negative 13.8 degrees. Now, here's the problem. We don't know what to do with negative 13.8 degrees. Doesn't make any sense. What do you do with negative 13.8 degrees? Now, but here's the big picture. What I need is this angle right here. Okay? If, this is a huge if it had been negative 19.2 and 4.7, I know that angle would be something a little bit less than 180 degrees. So if your calculator gives you a negative 13.8, take negative 13.8, add that to 180 degrees, you're going to get 170, or 164.2. Okay? That's the angle that you would get. Now, what I would do, and this is where the old dogs have an advantage. If it were me, I would not even mess with that negative sign. Honest to God, I wouldn't even mess with it. I would just take the inverse tangent of 4.7 and divide that by 19.2 and just get 13.8 degrees. Okay, don't even mess with this negative sign. This is what I would do. Then I'd find that angle and then I'd subtract it from 180. That way you don't have to muck around with negative signs. Now, if it had been down here in this third quadrant, where you had negative 19.2 and negative 4.7, and you're down in here, then you would add 13.8 degrees to 180. If you were over here and you had a negative x and a positive, or excuse me, a positive x and a negative y, you'd get 13.8 and you'd subtract that from 360. It's a personal preference thing, okay? All right, so let me give you some hints on some of your answers. So, when you do b plus e, the magnitude of that resultant should be around 14, and the angle should be around 100. Okay, so let me write that out. So when you do b plus e, the resultant is around 14 newtons at about 100 degrees. Okay, that's an ish. Okay, but it at least give you the ballpark. And then when you do c plus f, that resultant is going to be around 3 meters per second squared, and that angle is going to be at about 220 degrees. Okay? Those are just ballparks. So when you do b plus e, and you already have the x and y components, do these on another sheet of paper, keep them very organized, do not let these randomly run together. I want to see, oh, here's the sum of my x components. Here's the sum of my y components. Draw that new triangle. If you do it right, this is what you should get. Now, on number 6 and number 7, you're starting over from scratch. You've got to find all the x components, find all the y components, draw the resultant, the whole process. So if all goes well on number 6, the resultant should be around 15 newtons at about 75 degrees. And on number 7, that resultant should be around 10 newtons at around 170 degrees. Okay, so this will at least give you a ballpark to see if you did these right. And again, work these completely separate, work them on another sheet of paper. Do not try and cram this here. The only thing I want here is the sum of your x components, the sum of your y components, and the overall result. Same thing here. This is all I want written here. You're going to do all of this work on another sheet of paper. You're going to draw the big charts. You're going to keep everything organized. Okay. I am finally done. So we're going to shut this puppy down and call it a day.